In this episode of In the Weeds, we're going to take a close look at how we go about assessing the volatility of herbicides in the field, specifically in what we call low tunnel trials. In these trials, we commonly look at herbicides like dicamba, maybe 2,4-D, or even loyan, a herbicide that has caused some issues with rice applications here in the state of Arkansas. We're going to examine what we're putting in the tank. Does that increase the volatility? Does it potentially reduce the volatility? Or some of the tank additives that we have, are they truly effective in minimizing the volatility of certain herbicides? Come along and let's take a look at reducing the volatility of herbicides and assessing that in this episode of In the Weeds. When we take a look at the setup of a low tunnel volatility trial, it basically encompasses 20 feet of a tunnel that covers 2 rows of crop. As I'm showing here in this diagram, we're actually using soybeans as our 2 rows of crop. But if we were to be evaluating a herbicide such as 2,4-D, for which cotton has a high degree of sensitivity, we would actually be using cotton as our bioindicator. But here, as I'm showing in this diagram, we'd be using a herbicide like dicamba, possibly loyan or fluoroproxyfen benzyl in terms of the volatility of evaluations. You can see in the middle we have 2 flats of soil. These are moistened flats of soil, and they are then treated with the herbicide for which we want to evaluate. And we typically spray these flats 4 times to generate a 4x rate of the herbicide, because they are really only occupying a small area under the tunnel. We leave these flats in the tunnel for a 48-hour period in order to volatilize. During that period, we also have an air sampler in the center of this tunnel, and at the end of 48 hours, we will remove the air sample as well as the trays of soil, and then come back in and begin to take assessments within the field on the bioindicator crop at 14, 21, and 28 days after initiation of the experiment. Some might ask, well, how do you go about evaluating the sensitivity of the soybean? And what we ultimately do is we rate the degree of damage or injury that occurs to the crop. And underneath the tunnel, or where the tunnel once sat within the field, we break the plot into 8 quadrants, as seen here again in this photo. We'll rate these quadrants individually, and from that we can average the total extent of damage that occurred from our treatments. Again, this would be purely a function of volatility, as well as the fact that we can pick the quadrant in which the greatest amount of injury was observed, and we compare that back to our standard treatment, or the one treatment for which we're trying to understand, have we truly reduced volatility relative to that treatment. Another assessment that we take is we typically will measure from the center of the tunnel outwards some distance until we get to 5% injury. It's not uncommon with some of our standard treatments to have more than 5% injury in the center of the tunnel, and typically products may move upwards of 10 feet, which would be the edge of the tunnel, or even outside of the tunnel in regards to the degree of movement. We're now looking at a weather station. Inside of these tunnels, we typically will measure soil temperature as well as air temperature. It's typically in the tunnels we're generating a lot of heat, and it's really to give us an opportunity for the materials to volatilize and to assess, again, their relative volatility. But throughout, again, the 48-hour period, we record on a 5-minute interval the weather data associated. In this plot, we have dicamba plus glufosinate that was evaluated. This would be a DGA form of dicamba, similar to Clarity in combination with Liberty. that was sprayed again on the trays in the center of the plot. In this photograph here, we're 21 days after application, and again the flags are really marking the 8 quadrants, again ultimately 4 quadrants divided on with each row here on the left side and the right side to generate the areas in which we're going to assess. And what we notice, at least in this plot here, is we get a tremendous amount of volatility that came from this treatment, which is not surprising, again, of mixing dicamba and glufosinate. And really the goal here as we begin to move forward in how we conduct research is we understand that this is a comparison, and we're really trying to reduce volatility over what we see within this treatment. So hopefully we're going to be able to work towards discovering or even potentially working with industry to commercialize something that's going to reduce volatility beyond what we see with this treatment here. We're now looking at one of our better treatments where we've mixed one of our additives in with the dicamba glufosinate combination, and what we notice within the plot, there is very little, if any, volatility that has occurred based on the symptomology of the soybean. And again, I'll remind you that we're 21 days after the exposure here, and we assess these at 14, 21, and 28 days after treatment. And the level, is there damage here? Yes, there is a slight amount of damage, but overall tremendous reduction in volatility through the agent that we're evaluating in this trial here. I appreciate you tuning in again today to this episode of In the Weeds, and hopefully the information that we've shared today sheds some light on how we go about assessing the relative volatility of herbicides. Again, I look forward to seeing you next week on the next episode of In the Weeds.